Hello everyone, welcome back to my channel. This is Shravya. I'm currently pursuing my BE second year in Sri Venkateshwara College of Engineering. In this video, I'm going to discuss about the subject mathematics. In that, my topic is Anova. First of all, let me give some introduction to Anova. Means analysis of variance is a statistical method used to test for differences between two or more population means that is called Anova. And it helps to determine if there is a significant difference in the means of different groups, and this ANOVA is commonly used in search studies to compare the effect of multiple factors on a dependent variable. Means it analyzes the variance of statistical method and it helps to determine the significant differences in the means, and it is commonly used to research studies to compare the effect of multiple factors on dependent variable. And next is we have the types of ANOVA. That means one is one-way ANOVA and second one is two-way ANOVA and third one is factorial ANOVA. That one-way ANOVA means it is used when there is only one independent variable with more than two levels. And the second one is two-way ANOVA. It is used when there are two independent variables and their interaction effect on the dependent variable needs to be studied. And this next is factorial ANOVA, that is used when there are two or more independent variables that are manipulated in a factorial design. And next is assumption of ANOVA. Let us know some assumptions of ANOVA. In this we have three types. One is independence and second one is normality and third one is homogeneity of variances. In this, independence means the observations in each group are independent of each other. Means these observations are this observation is independent for each group in each other. And the normality means the residuals of the model should be normally distributed. Means the model should be normally distributed in this normality. And the homogeneity of variances means these variances within each group should be equal. Next, we have null and alternative hypothesis. In this, null hypothesis means HO HO is the full form of this, and there is no significant differences between the means of groups. And the alternative hypothesis, we call it as a HA, and there is a significant differences between the means of these groups. And this ANOVA calculates the F statistic to test the null hypothesis. And we have the calculating the F statistic. In that, the F statistic is calculated as the ratio of the mean square between groups to the mean square within groups. If the F static is greater than the critical value, we reject the null hypothesis. And the degrees of freedom for the F statistic are based on the number of groups and sample size. Nothing but this calculating the F static is used to find the ratio of the mean square it between the group to the mean square within groups. And this F static is greater than the crucial values, but it will reject the null hypothesis. And these degrees of freedom for the F static are based on the number of groups and sample size. And we have interrupting ANOVA results. It means if the p value is less than significance level, commonly it is in 0.05. We reject the null hypothesis. As if p value is less than significant level, it rejects the null hypothesis. And well, post hoc tests such as Tuckey's HSD or Bonferroni can be conducted to determine which specific groups differ significantly. And this ANOVA does not provide information on which the specific group means the different from each other. And we have the advantages of ANOVA. This ANOVA can handle multiple groups simultaneously, and it reducing the likelihood of type 1 errors. And it has a powerful statistical tool for comparing means and identifying significant differences. And this ANOVA can provide insights into the relationships between multiple factors and the dependent variables. And we have the limitations of ANOVA. This ANOVA assumes that the data is normally distributed and that variances are equal across these groups. It means if we assume that the idea is normally distributed and that variants are equally across the groups, it does not provide information on the direction or magnitude of differences between specific group means. And this ANOVA can be sensitive to outliers and violations of assumptions. And we have the applications of ANOVA. ANOVA is widely used in experimental research to compare the effects of different treatments or interventions. Means this ANOVA is used experimentally in research to compare the effectiveness of different treatments or inventions. And it is used in quality control to access the variability in manufacturing the process. Means by manufacturing the process, we use the quality control. And this ANOVA is also applied in social sciences, biology, physics, psychology, and various other fields for statistical analysis. It is basically used in all applied in social sciences, biology, psychology, and various other fields for statistical analysis. And I'm going to conclude this topic. This ANOVA is a valuable statistical tool for comparing means across multiple groups and identifying significant differences. Means it is a valuable statistical tool by means of across multiple groups and identifying significant differences. And understanding the assumptions, calculations, and interpretations of ANOVA results is essential for conducting valid statistical analysis. When we use this appropriately, ANOVA can provide valuable insights into the relationships between factors and a dependent variable in research studies. Thank you.